Chapter 5 of How It Flies, or Conquest of the Air. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information, or to volunteer, please visit LibriVox.org. How It Flies, or Conquest of the Air, by Richard Ferris. Chapter 5 Flying Machines, the Biplane. In the many contests for prizes and records, two types of flying machines have won distinctive places for themselves, the biplane and the monoplane. The appearance of other forms has been sporadic, and they have speedily disappeared without accomplishing anything which had not been better done by the two classes named. This fact, however, should not be construed as proving the futility of all other forms, nor that the ideal flying machine must be of one of these two prominent types. It is to be remembered that record-making and record-breaking is the most serious business in which any machines have so far been engaged, and this, surely, is not the field of usefulness to humanity which the ships of the air may be expected ultimately to occupy. It may yet be proved that, successful as these machines have been in what they have attempted, they are but transition forms leading up to the perfect airship of the future. The distinguishing feature of the biplane is not alone that it has two main planes, but that they are placed one above the other. The double or tandem monoplane also has two main planes, but they are on the same level, one in the rear of the other. A review of the notable biplanes of the day must begin with the Wright machine, which was not only the first with which flights were made, but also the inspiration, and perhaps the pattern, of the whole succeeding fleet. The Wright biplane. The Wright biplane is a structure composed of two main surfaces, each 40 feet long and 6 feet 6 inches wide, set one above the other, parallel, and 6 feet apart. The planes are held rigidly at this distance by struts of wood, and the whole structure is trussed with diagonal wire ties. It is claimed by the Wrights that these dimensions have been proven by their experiments to give the maximum lift with the minimum weight. The combination of planes is mounted on two rigid skids, or runners, similar to the runners of a sleigh, which are extended forward and upward to form a support for a pair of smaller planes in parallel, used as the elevator, for directing the course of the aeroplane upward or downward. It has been claimed by the Wrights that a rigid skid understructure takes up the shock of landing, and checks the momentum at that moment better than any other device. But it necessitated a separate starting apparatus, and while the starting impulse thus received enabled the Wrights to use an engine of less power, to keep the machine going when once started, and therefore of less dead weight, it proved a handicap to their machines in contests where they were met by competing machines which started directly with their own power. A later model of the Wright biplane is provided with a wheeled running gear, and an engine of sufficient power to raise it in the air after a short run on the wheels. Two propellers are used, run by one motor. They are built of wood, are of the two-bladed type, and are of comparatively large diameter, 8 feet. They revolve in opposite directions at a speed of 450 revolutions per minute, being geared down by chain drive from the engine speed of 1,500 revolutions per minute. The large elevator planes in front have been a distinctive feature of the Wright machine. They have a combined area of 80 square feet, adding that much more lifting surface to the planes in ascending, for then the underside of their surfaces is exposed to the wind. If the same surfaces were in the rear of the main planes, their top sides would have to be turned to the wind when ascending, and a depressing instead of a lifting effect would result. To the rear of the main planes is a rudder composed of two parallel vertical surfaces for steering to right or left. The feature essential to the Wright biplane, upon which the letters patent were granted, is the flexible construction of the tips of the main planes, in virtue of which they may be worked up or down to restore disturbed equilibrium, or when a turn is to be made. This warping of the planes changes the angle of incidence for the part of the plane which is bent. The angle of incidence is that which the plane makes with the line in which it is moving. The bending downward of the rear edge would enlarge the angle of incidence, in that way increasing the compression of the air beneath and lifting that end of the plane. The wing warping controls are actuated by the lever at the right hand of the pilot, which also turns the rudder at the rear, that which steers the machine to right or left. The lever at the left hand of the pilot moves the elevating planes at the front of the machine. Sketch showing relative positions of planes and of the operator in the Wright machine. The motor has 4 cylinders, and develops 25 to 30 horsepower, giving the machine a speed of 39 miles per hour. A newer model of the Wright machine is built without the large elevating planes in front, a single elevating plane being placed just back of the rear rudder. This arrangement cuts out the former lifting effect described above, and substitutes the depressing effect due to exposing the top of a surface to the wind. The smallest of the Wright machines, popularly called the "Baby Wright," is built upon this plan, and has proven to be the fastest of all the Wright series. The Voisin biplane. While the Wrights were busily engaged in developing their biplane in America, a group of enthusiasts in France were experimenting with gliders of various types, towing them with high-speed automobiles along the roads or with swift motorboats upon the Seine. As an outcome of these experiments, in which they bore an active part, the Voisin brothers began building the biplanes which have made them famous. As compared with the Wright machine, the Voisin aeroplane is of much heavier construction. It weighs 1,100 pounds. The main planes have a lateral spread of 37 feet 9 inches, and a breadth of 7 feet, giving a combined area of 540 square feet, the same as that of the Wright machine. The lower main plane is divided at the center to allow the introduction of a trussed girder framework which carries the motor and propeller, the pilot's seat, the controlling mechanism, and the running gear below, and it is extended forward to support the elevator. This is much lower than in the Wright machine, being nearly on the level of the lower plane. It is a single surface, divided at the center, half being placed on each side of the girder. It has a combined area of 42 square feet, about half of that of the Wright elevator, and it is only 4 feet from the front edge of the main planes, instead of 10 feet as in the Wright machine. A framework nearly square in section, and about 25 feet long, extends to the rear, and supports a cellular or box-like tail, which forms a case in which is the rudder surface for steering to right or to left. A distinctive feature of the Voisin biplane is the use of 4 vertical planes, or curtains, between the 2 main planes, forming 2 nearly square cells at the end of the planes. At the rear of the main planes, in the center, is the single propeller. It is made of steel, 2-bladed, and is 8 feet 6 inches in diameter. It is coupled directly to the shaft of the motor, making with it 1,200 revolutions per minute. The motor is of the V type, developing 50 horsepower and giving a speed of 37 miles per hour. Diagram showing the simplicity of control of the Voisin machine, all operations being performed by the wheel and its sliding axis. The controls are all actuated by a rod sliding back and forth horizontally in front of the pilot's seat, having a wheel at the end. The elevator is fastened to the rod by a crank lever and is tilted up or down as the rod is pushed forward or pulled back. Turning the wheel from side to side moves the rudder in the rear. There are no devices for controlling the equilibrium. This is supposed to be maintained automatically by the fixed vertical curtains. Voisin biplanes at the starting line at Reims in August, 1909. They were flown by Louis Paulhan, who won 3rd prize for distance, and Henri Rougier, who won 4th prize for altitude. In the elimination races to determine the contestants for the Bennett Cup, Paulhan won 2nd place with the Voisin machine, being defeated only by Tissandier with a Wright machine. Other noted aviators who fly the Voisin machine are M. Bunau Varilla and the Baroness de la Roche. The machine is mounted on 2 wheels forward and 2 smaller wheels under the tail. This description applies to the standard Voisin biplane, which has been in much favor with many of the best known aviators. Recently the Voisins have brought out a new type in which the propeller has been placed in front of the planes, exerting a pulling force upon the machine, instead of pushing it as in the earlier type. The elevating plane has been removed to the rear, and combined with the rudder. A racing type also has been produced, in which the vertical curtains have been removed, and a parallel pair of long, narrow ailerons introduced between the main planes on both sides of the center. This machine, it is claimed, has made better than 60 miles per hour. The first Voisin biplane was built for Delagrange, and was flown by him with success. The Farman biplane. The second biplane built by the Voisins went into the hands of Henri Farman, who made many flights with it. Not being quite satisfied with the machine, and having an inventive mind, He was soon building a biplane after his own designs, and the Farman biplane is now one of the foremost in favor among both professional and amateur aviators. It is decidedly smaller in area of surface than the Wright and Voisin machines, having but 430 square feet in the two supporting planes. It has a spread of 33 feet, and the planes are 7 feet wide, and set 6 feet apart. In the Farman machine the vertical curtains of the Voisin have been dispensed with. The forward elevator is there, but raised nearly to the level of the upper plane, and placed 9 feet from the front edge of the main planes. To control the equilibrium, the two back corners of each plane are cut and hinged so that they hang vertically when not in flight. When in motion these flaps or ailerons stream out freely in the wind, assuming such position as the speed of the passing air gives them. They are pulled down by the pilot at one end or the other, as may be necessary to restore equilibrium, acting in very much the same manner as the warping tips of the Wright machine. A pair of tail planes are set in parallel on a framework about 20 feet in the rear of the main planes and a double rudder surface behind them. Another model has hinged ailerons on these tail planes, and a single rudder surface set upright between them. These tail ailerons are moved in conjunction with those of the main planes. The Farman biplane, showing the position of the hinged ailerons when at rest. At full speed these surfaces stream out in the wind in line with the planes to which they are attached. The motor has 4 cylinders, and turns a propeller made of wood, 8 feet 6 inches in diameter, at a speed of 1,300 revolutions per minute, nearly 3 times as fast as the speed of the Wright propellers, which are about the same size. The propeller is placed just under the rear edge of the upper main plane, the lower one being cut away to make room for the revolving blades. The motor develops 45 to 50 horsepower, and drives the machine at a speed of 41 miles per hour. The racing Farman is slightly different, having the hinged ailerons only on one of the main planes. The reason for this is obvious. Every depression of the ailerons acts as a drag on the air flowing under the planes, increasing the lift at the expense of the speed. Sketch of Farman machine, showing position of operator. The whole structure is mounted upon skids with wheels attached by a flexible connection. In case of a severe jar, the wheels are pushed up against the springs until the skids come into play. The elevator and the wing naps are controlled by a lever at the right hand of the pilot. This lever moves on a universal joint, the side-to-side movement working the flaps, and the forward and back motion the elevator. Steering to right or left is done with a bar operated by the feet. Henri Farman carrying a passenger cross-country. Farman has himself made many records with his machine, and so have others. With a slightly larger and heavier machine than the one described, Farman carried 2 passengers a distance of 35 miles in 1 hour. The Curtiss biplane. This American rival of the Wright biplane is the lightest machine of this type so far constructed. The main planes are but 29 feet in spread, and 4 feet 6 inches in width, and are set not quite 5 feet apart. The combined area of the two planes is 250 square feet. The main planes are placed midway of the length of the fore and aft structure, which is nearly 30 feet. At the forward end is placed the elevator, and at the rear end is the tail, one small plane surface, and the vertical rudder surface in 2 parts, one above and the other below the tail plane. Equilibrium is controlled by changing the slant of 2 small balancing planes which are placed midway between the main planes at the outer ends, and in line with the front edges. These balancing planes are moved by a lever standing upright behind the pilot, having 2 arms at its upper end which turn forward so as to embrace his shoulders. The lever is moved to right or to left by the swaying of the pilot's body. The motor is raised to a position where the shaft of the propeller is midway between the levels of the main planes, and within the line of the rear edges, so that they have to be cut away to allow the passing of the blades. The motor is of the V type with 8 cylinders. It is 30 horsepower and makes 1,200 revolutions per minute. The propeller is of steel, 2-bladed, 6 feet in diameter, and revolves at the same speed as the shaft on which it is mounted. The high position of the engine permits a low running gear. There are 2 wheels under the rear edges of the main planes, and another is placed halfway between the main planes and the forward rudder, or elevator. A brake, operated by the pilot's foot, acts upon this forward wheel to check the speed at the moment of landing. Another type of Curtiss machine has the ailerons set in the rear of the main planes instead of between them. The Curtiss is the fastest of the biplanes, being excelled in speed only by some of the monoplanes. It has a record of 51 miles per hour. The Cody biplane. The Cody biplane has the distinction of being the first successful British aeroplane. It was designed and flown by Captain S. F. Cody, at one time an American, but for some years an officer in the British Army. It is the largest and heaviest of all the biplanes, weighing about 1,800 pounds, more than 3 times the weight of the Curtiss machine. Its main planes are 52 feet in lateral spread and 7 feet 6 inches in width, and are set 9 feet apart. The combined area of these sustaining surfaces is 770 square feet. The upper plane is arched, so that the ends of the main planes are slightly closer together than at the center. The elevator is in 2 parts placed end to end, about 12 feet in front of the main planes. They have a combined area of 150 square feet. Between them and above them is a small rudder for steering to right or left in conjunction with the large rudder at the rear of the machine. The latter has an area of 40 square feet. There are 2 small balancing planes, set one at each end of the main planes, their centers on the rear corner struts, so that they project beyond the tips of the planes and behind their rear lines. The biplane is controlled by a lever rod having a wheel at the end. Turning the wheel moves the rudders. Pushing or pulling the wheel works the elevator. Moving the wheel from side to side moves the balancing planes. There are 2 propellers, set one on each side of the engine, and well forward between the main planes. They are of wood, of the 2-bladed type, 7 feet in diameter. They are geared down to make 600 revolutions per minute. The motor has 8 cylinders and develops 80 horsepower at 1,200 revolutions per minute. The machine is mounted on a wheeled running gear, 2 wheels under the front edge of the main planes, and one a short distance forward in the center. There is also a small wheel at each extreme end of the lower main plane. The Cody biplane has frequently carried a passenger, besides the pilot, and is credited with a speed of 38 miles per hour. The first aeroplane flights ever made in England were by Captain Cody on this biplane, January 2, 1909. The Sommer biplane. The Sommer biplane is closely similar to the Farman machine, but has the hinged ailerons only on the upper plane. Another difference is that the tail has but one surface, and the rudder is hung beneath it. Its dimensions are: spread of main planes 34 feet, depth fore and aft 6 feet 8 inches, they are set 6 feet apart. The area of the main planes is 456 square feet, area of tail 67 square feet, area of rudder 9 square feet. It is driven by a 50 horsepower Gnome motor turning an 8-foot 2-bladed propeller. M. Sommer has flown with 3 passengers, a total weight of 536 pounds, besides the weight of the machine. The Baldwin biplane. The Baldwin biplane, designed by Captain Thomas S. Baldwin, the distinguished balloonist, resembles the Farman type in some features, and the Curtiss in others. It has the Curtiss type of ailerons, set between the wings, but extending beyond them laterally. The elevator is a single surface placed in front of the machine, and the tail is of the biplane type with the rudder between. The spread of the main planes is 31 feet 3 inches, and their depth 4 feet 6 inches. A balancing plane of 9 square feet is set upright, like a fin, above the upper main plane on a swivel. This is worked by a fork fitting on the shoulders of the pilot, and is designed to restore equilibrium by its swinging into head resistance on one side or the other, as may be necessary. The motive power is a 4-cylinder Curtiss motor, which turns a propeller 7 feet 6 inches in diameter, set just within the rear line of the main planes, which are cut away to clear the propeller blades. The Baddeck biplane. The newest biplane of the Aerial Experiment Association follows in general contour its successful precursor, the Silver Dart, with which J. A. D. McCurdy made many records. The Baddeck No. 2 is of the biplane type, and both the planes are arched toward each other. They have a spread of 40 feet, and are 7 feet in depth at the center, rounding to 5 feet at the ends, where the wing tips, 5 feet by 5 feet, are hinged. The elevator is also of the biplane type, 2 surfaces each 12 feet long and 28 inches wide, set 30 inches apart. This is mounted 15 feet in front of the main planes. The tail is mounted 11 feet in the rear of the main planes, and is the same size and of the same form as the elevator. The controls are operated by the same devices as in the Curtiss machine. The propeller is 7 feet 8 inches in diameter, and is turned by a 6-cylinder automobile engine of 40 horsepower running at 1,400 revolutions per minute. The propeller is geared down to run at 850 revolutions per minute. The motor is placed low down on the lower plane, but the propeller shaft is raised to a position as nearly as possible that of the center of resistance of the machine. That speed attained is 40 miles per hour. A unique feature of the mechanism is the radiator, which is built of 30 flattened tubes 7 feet 6 inches long, and 3 inches wide, and very thin. They are curved from front to rear like the main planes, and give sufficient lift to sustain their own weight and that of the water carried for cooling the cylinders. The running gear is of 3 wheels placed as in the Curtiss machine. The Baddeck No. 2 has made many satisfactory flights with one passenger besides the pilot. The Herring biplane. At the Boston Aircraft Exhibition in February, 1910, the Herring biplane attracted much attention, not only because of its superiority of mechanical finish, but also on account of its 6 triangular stabilizing fins set upright on the upper plane. Subsequent trials proved that this machine was quite out of the ordinary in action. It rose into the air after a run of but 85 feet, and at a speed of only 22 miles per hour, and made a 40-degree turn at a tipping angle of 20 degrees. As measured by the inventor, the machine rose in the air with the pilot, weighing 190 pounds, with a thrust of 140 pounds, and required only a thrust of from 80 to 85 pounds to keep it flying. The spread of the planes is 28 feet, and they are 4 feet in depth, with a total supporting surface of 220 feet. A 25 horsepower Curtiss motor turns a 4-bladed propeller of 6 feet diameter and 5-foot pitch, designed by Mr. Herring, at the rate of 1,200 revolutions per minute. The elevator consists of a pair of parallel surfaces set upon hollow poles 12 feet in front of the main planes. The tail is a single surface. The stabilizing fins act in this manner. When the machine tips to one side, it has a tendency to slide down an incline of air toward the ground. The fins offer resistance to this sliding, retarding the upper plane, while the lower plane slides on and swings as a pendulum into equilibrium again. The Breguet biplane. The Breguet biplane is conspicuous in having a biplane tail of so large an area as to merit for the machine the title tandem biplane. The main planes have a spread of 41 feet 8 inches, and an area of 500 square feet. The tail spreads 24 feet, and its area is about 280 square feet. The propeller is 3-bladed, 8 feet in diameter, and revolves at a speed of 1,200 revolutions per minute. It is placed in front of the main plane, after the fashion of the monoplanes. The motive power is an 8-cylinder REP engine, developing 55 horsepower. End of Chapter 5.